All right, as I promised, special angles, and in this particular video I'm going to be providing or performing calculations on questions that were previously written on other exam papers, right? So first thing which you need to understand is that if you encounter a question that says without the use of a calculator, they want you to draw these triangles or special angles. One, the first one which I drew here, it's a what? It's a scaling because it has got three unequal angles and three unequal sides. The second one is your isosceles triangle, which has got two equal sides and yes, it has got two equal sides and two equal angles. All right, so let's start with this question. We are given negative sin squared 30 degrees multiplied by tan 60 degrees. So what is it that I know? I have to go to my scaling triangle here because now they want me to provide sin 30 degrees. So when I come to this 30 degrees, I now say, where is my opposite? My opposite is this side. Here, it's 1. And then my hypotenuse is 2. So I now come and I write that negative, open bracket, 1 over 2, close bracket, the squared I write it outside, right? And it's being multiplied by tan 60. I go back to the same scaling triangle, this time around to a different angle, which is tan 60 degrees. And tan says opposite over adjacent. My opposite here is what? Square root of 3, right? And my adjacent is 1. And square root of 3 over 1 is equals to square root of 3. So I come here and I say multiplied by square root of 3 over 1. All over what? All over my cos 60 degrees. So if I'm here at cos, now it's adjacent over hypotenuse. My adjacent is 1, my hypotenuse is 2. So I write that it is all over 1 over 2. Now, I mustn't forget my BODMAS rule when I'm now going to start calculating. Why am I talking about the BODMAS rule? Because I must come and first deal with the brackets and this exponent. So I'm going to repeat writing the what? The negative. And then I'm going to open the bracket. Now, remember you've got law number 3. What is it that law number 3 tells us? Law number 3 tells us that if I'm given something like this, under my laws of exponents, and to the power of 2 like this, it means that the numerator, the exponent of the numerator will multiply with the exponent outside, and the exponent of the denominator will multiply with this exponent. So if we say 1 multiplied by 2, it will give us what? It will give us 2 all over. 1 multiplied by 2 is another 2, so we've got 2 to the power 2. And 1 to the power 2 gives us what? It gives us 1 all over. 2 to the power 2 gives us what? 4. So we've got 1 over 4. So here we have found that it is equals to 1 over 4. It's still inside the brackets. Why? Because we still have to multiply this positive with this negative. Hence, we didn't remove the brackets, right? And we still have got what? Multiplied by square root of 3 over 1. And then we still have got what? 1 over 2 as our denominator. So the next thing that we're going to do now, we've got a negative 1 over 4 here, which is multiplying with the square root of 3 over 1. And it is all over 1 over 2. Now when I say 1 multiplied by square root of 3, I know that the answer is equals to what? Square root of 3 over 4 multiplied by 1, it gives me 4. But unlike everywhere I've been placing the over 1 over 2, if I place this over here, it's mathematically correct, but for most students, it confuses them. So what do I recommend? This is a division sign. So I recommend that you place a division sign here. And then you say 1 over 2. Now we have to use the KCF method. KCF method. KCF stands for what? K stands for keep. What are we keeping? We're keeping this fraction here. So on the next stage now, I keep square root of 3 over 4. And then the C stands for change. We are changing this sign. It was a division. Now it's going to be a multiplication. Then F stands for flip. So we're going to flip 2. The numerator becomes the denominator becomes the numerator. So now we've got 2 over 1. And do not make the mistake which I was about to make. When I multiplied here, I forgot this negative. So negative multiplied by a positive, it's a negative. So here there is a negative. So, which means I must carry on with my negative here. It's a good thing that I observed the mistake before I came to the final answer. Now, observe another thing here. I've got 2 and I've got 4 here. What happens with these two? They've got a common factor of 2. So I say 2 into 2, it's 1. 2 into 4, it's what? It's 2. And then I now say negative multiplied by positive, it gives me a negative. And square root of 3 multiplied by 1 is 2 square root of 3 all over 2 multiplied by 1 is equals to 2. And just like that, we are done. Right? So that is how you calculate. All right. So let's go to the next question. I'm just going to erase here so that we can have more space to work with. So when you use your triangle, the triangles of special angles, then it becomes very easy for you to calculate. Please note that if you try to cheat by using a calculator, the examiner will know and then you lose marks. So it's easy. Go and check the video where I introduced how should you remember these special angles. That's why I'm not talking about it today. All right. So the next question says sin 45 degrees plus cos 45 degrees all over tan 45 degrees. We must solve without using a calculator. So we start with sin 45. Now we are using this isosceles. This is what 45 degrees, and sin implies opposite over hypotenuse. So we've got 1 over square root of 2. So we write our 1 over square root of 2 plus cos 45 degrees. Cos, we're still here at 45. It is adjacent over hypotenuse. Another 1 over square root of 2. So we've got 1 over square root of 2. Then we've got tan 45. So this is all over. Tan 45, it's opposite over adjacent. 1 over 1, which means that here we've got 1. All right. Then when we are done doing that, now we say is equal to. If you observe here, I have square root of 2 and square root of 2 here. So the denominators are common. So I'm going to add the numerators. So I've got 2 over square root of 2. But I know that dividing by 1 is useless or pointless because the answer remains what it is. However, now we cannot, or we are not allowed to what? To have a denominator which is an irrational number. So we must remove this irrational number, which is what we call rationalizing the denominator. How do I remove it? I multiply by the very same denominator. But in order for me not to change the value, I'm now going to use a conjugate. This is when I take this number. Now I say numerator is square root of 2 over denominator square root of 2. Square root of 2 over square root of 2, if I divide them, they give me 1. That is the concept of a conjugate, that I did not change this number, even though I did not use 1, but I also multiplied by 1 because these two, they are what? They are equal to 1. Anyway, when I proceed now, 2 multiplied by square root of 2, the answer I get is 2 square root of 2 all over. Square root of 2 multiplied by square root of 2, it gives me square root of 4. So I've got square root of 4 here. However, square root of 4, this is a square root of a perfect square. So what do? It means that I must simplify it. So I write my numerator of 2 square root of 2 over square root of 4 is equal to 2. And there we go. And just like that, we are done. I have answered the question, right? It was not a train smash at all. Now, we go to the next question. What does it say? The next question now says, I have sin 45 degrees, and then this is all over square root of 2. So I'm given square root of 2, multiplied by tan squared 30 degrees, tan squared 30 degrees. So there's a division line there. Now, if we go back to sin 45, we just found out that it was 1 over square root of 2 when we did that. So we now say here we have got 1 over square root of 2 all over. We still have got on our denominator square root of 2 over 2 multiplied by tan squared 30 degrees. This is where the 30 degrees is, and tan is opposite. This is the opposite side of angle 30. 1 opposite over adjacent, and this is the adjacent side. So we've got 1 over square root of 3. So multiplied by 1 over square root of 3 like that. Now, there is nothing that we can do at the moment with the numerator. So we just simply rewrite 1 over square root of 2 all over. Now we're going to multiply here. Now we say what? 2 square root of 2 multiplied by 1, which gives me a square root of 2 all over. 2 multiplied by square root of 3, it gives me what? But you're doing grade 10, so I think it's best if I don't start by multiplying these. What am I going to do? Let me show you a trick so that you don't complicate your life as a grade 10. So you write square root of 2 here over 2 multiplied by. Now I've got 1 over square root of 3 here, and remember what I said, we do not want to work with this irrational number. Check, I extended my division line. So what do? I now introduce making this a rational number. So I say multiply by my conjugate square root of 3 over square root of 3. Then from there, now I repeat writing 1 square root of 2. So I say on the next stage I've got 1 over square root of 2 all over. I still have got square root of 2 over 2 being multiplied by. Now I come here and I say 1 times square root of 3, it's square root of 3. So we've got square root of 3 here over. And when we say square root of 3 multiplied by square root of 3, this gives us square root of 9. So here we've got square root of 9. Then I continue. I still have got, oh, I do not know why didn't I do this actually with the numerator. Luckily I can still do that so that I can get rid of this as well. So I say square root of 2. Oh, I was supposed to do it here. Let me do it here on this stage. So I say square root of 2 over square root of 2. 1 times square root of 2, it gives me square root of 2. So here I'm going to remove this and write my numerator of square root of 2 all over. And when I say square root of 2 times square root of 2 is square root of 4. So there I have got square root of 4. On the next stage, I repeat my numerator, which is square root of 2 over. My square root of 4 is equal to 2, so I write my 2 there. Now, what do? Here, I say all over. I still repeat the square root of 2 over 2 multiplied by. Now, square root of 3, I write my square root of 3. And what is square root of 9? Square root of 9 is a 3. So, square root of 3 over 3. Now on the next stage, square root of 2 over 2. Now I'm going to multiply or observe. And now I've got a rational number. So my denominator is now fine. I can proceed. Square root of 2 multiplied by square root of 3. What do we get? We get square root of 6. So we've got square root of 6 here all over. 2 times 3 is equal to 6. We've got square root of 6 like this. So on the next stage, this is what I'm now going to do. Now I'm going to write square root of 2. So I say is equals to square root of 2 over 2. This division line, I'm no longer using it. I use the division which you are used to. Then I write my square root of 6 over 6. Square root of 2 over 2. Then we change the division line. It becomes multiplication. We flip here. Now we've got 6 over square root of 6 here. Now observe these two, they've got what? These two have got a common factor, which is 2. So 2 into 2, 1, 2 into 6 is 3, which is now equal to, if I multiply 3 multiplied by square root of 2, it gives me 3 square root of 2 all over here. I've got square root of 6. Square root of 6. And I don't want to work with this square root of 6, or yeah, so I multiply by square root of 6 over square root of 6. Now these two, they cannot multiply each other, but these roots, they can multiply each other, and 6 times 2 is equals to 12. So I've got 3 square root of 12 all over square root of 6 times square root of 6, it gives me 36. So I've got square root of 36. But square root of 36 is a root of a perfect square, which now brings me to the final answer of 3 square root of 12 all over 6. But it's not the final answer, because 3 and 6, they've got a common factor. So 3 into 3, 1, and 3 into 6 is 2. So my final answer is actually square root of 12 over 2. This is the final answer. All right. I hope so. The work is a little bit tedious. It's a lot of work, but it's very easy when you know what you're doing. It's very easy. All right. So on the next video, I'm going to be dealing with trig equations. Please do join us on the next equation, and I'm only dealing with questions from past exam papers. Please do share, like, comment, and subscribe. That is how we grow the channel. Thank you.